Hi, I'm Daniel Halsey.
I'm JB Sharma.
At the University of North Georgia. I want to give you a little bit of a tour of the EV by SenseFly that we've been flying. This is an autonomous drone that, again, is made by the company called SenseFly. It's a blended wing design. It's got about a 3-foot wingspan, and it really only has 2 control surfaces. We've got 2 surfaces in the back, and these act as both elevators and as ailerons, all controlled by the autonomous software that comes in the drone. This drone is packed with sensors. It obviously has a GPS unit that it uses to acquire its position very accurately. It also has a pitot and static tube that it uses to get its airspeed and its altitude from. It has, on the bottom here, it has a ground sensor that it uses when it's coming in to land itself. It actually senses how far it is from the ground and uses that to coordinate its automated landing. The drone has an antenna on top that it uses to connect to the computer that's being flown off of through a wireless modem. So when a flight's programmed into the drone, the actual flight is downloaded to the drone's autopilot system, but it's also controlled through the computer at the same time. When we fly this drone, we fly one of 2 cameras that we have so far. The drone has this bay on the bottom with a port for the camera aperture to see out of. The camera is actually held within this bay on the drone, and so like I said, we have 2 cameras that came with it, and these are just Canon point-and-shoot cameras that have been hacked into that allow them to be used with this drone. One cool thing about this one is that it's been hacked into and been made to work in the near-infrared region of the EM spectrum. So this one allows us 3 bands of near-infrared, red and green, whereas this one gives us red, green, and blue imagery. So you can see some of the examples behind me of some of the imagery we were able to take. This is our science building at University of North Georgia, and you can see that we were able to acquire imagery over the whole thing. It was all mosaic together after the flight to get one continuous product out of it. This over here is imagery of an event that we took. This was the club fair at UNG, so you can kind of see the benefit of being able to go up and quickly take your own flights of an event to document what happened there. And again, both of these are done with our RGB camera, red, green, blue. Here's an example of some imagery that we took from our near-infrared camera. Having this near-infrared capability allows us to do a lot of indexing with the different bands of imagery, whereas we can take this near-infrared band and we can do things like a vegetation index to give us an indication of health of a lot of the plants around campus or anywhere that the drone is flown. Another thing that this drone is very useful for is to generate 3D models through photogrammetry. The post-flight software that it came with actually generates 3D models for us. And I'll pan around here so you can see this model move. Again, this model is taken in the near infrared, so it's not a color model, but you can see that it makes a very accurate model of whatever terrain this drone is flown over. So this can allow a lot of engineering type uses for the drone by being able to generate a model like this. It can also be used in a lot of water flow type studies as well.
We are really into mapping over here, and mapping includes mapping the macrocosm, and so we are using technologies like the EB-UAS. So it's really not an unmanned aerial vehicle, it's an unmanned aerial system, because This system has an autonomous flight, and it is incomplete without a laptop that is controlling it and the modem that is communicating with it, and that is to map the macrocosm. But at the same time, we have an atomic force microscope in physics in which we can map out the surfaces down to nanometer levels. Well, it turns out that as a society, we are getting increasingly wired up with sensors. So there are sensors getting to be everywhere in our society that are crunching out terabytes of data. And the whole idea is that how do you take this big data, this age of big data that we are getting into, and how do we convert this data to actionable information that can benefit society? So how can society become more efficient in its processes such that we can live more sustainably, we can have a cleaner environment, we can do several processes like remote sensing of the environment, or maybe even delivering things like Amazon is interested in using this type of technology. So there are many, many applications that exist for this, and there are many more that are yet undreamed of that we will be developing in the next coming decades. I'm J.B. Sharma, and I'm a professor of physics and remote sensing.
I'm Daniel Halsey from the University of North Georgia Institute for Environmental Spatial Analysis. I'm a student studying drone research.